Good morning, evening, afternoon, and evening from wherever you are joining us today. And we welcome back to the another episode from the Azure Load Testing series. My name is Rashmita, and I'm the event planner for Microsoft Reactor India. Today, I'm joined by our very own host, Nikita. But before I hand over the floor to her, I would request you all to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section is open throughout, and we do encourage you all to participate. Our speaker will answer all your questions during the session. So please feel free to drop all your questions in the chat section. With this, thank you all. Enjoy the session, and let me bring in Nikita to the stream. Over to you, Nikita.
Thanks, Rashmita. Hi, everyone. I'm Nikita. I'm a product manager working for Azure Load Testing. Today, we are going to talk about a topic where it'll help you get ready for your holiday ready holiday shopping season. So, we are going to talk about how you can test different Azure services, and we'll take example of different services and how you can go about it. If you have followed our series from the past few weeks, you would have gone through how to use JMeter, how to get started with Azure load testing, how to do integrate it into your CI/CD pipelines, and different topics like how you can do chaos testing and how to test your AKS infrastructure using Azure load testing. So now we are towards the end of the series. We want to talk about how to do how to what to look when you are load testing different Azure services. We'll talk about some with HTTP protocol, some with non-HTTP protocol, and how you can do that in JMeter and Azure load testing. So, so whether you're a developer, an IT professional, I think you will get some valuable insights from this session, and which you can apply to your testing for your production workloads as well. So first of all, this is the agenda. We will talk about how can you prepare for load testing in these scenarios, how we can test different services, some services that we are going to talk about, app service, SQL database, a service bus, which is messaging queue. And then we talk about an end-to-end scenario where from APIM to Cosmos DB, there are different services involved. It's an end-to-end integration of services. So we are going to talk about how you would load test these and what are the different performance metrics you would want to look for these in for each of these. Then we talk about some best practices that you might want to keep in mind while load testing, and then we'll take questions if there are any. So you might wonder why you want to, if you want to test, say, each of these services separately, wouldn't it be enough if you just test the uh, endpoint? For example, if there's a website, if you directly load test the website, is that enough? Because it internally uses, say, a database or any other service as well involved, right? Why would you want to test a database separately? So there are quite a few scenarios. One scenario could be that you have a microservice architecture where you have some common components and some components which are specific to a microservice. You might want to test them in isolation to make sure you are able to isolate the performance bottlenecks for each service, and you're able to identify those separately. There could be instances where your database is used by multiple services. So just testing one service at a time may not be enough. So might want to test the database itself to make sure it's able to scale and give you the performance that you want. So while you do need to do the end-to-end testing, it's also important that you test each of these components individually. So let's talk about how you can prepare for load testing. So it's very important that you set up your Azure resources. So ideally, you might not want to do it on your production resources. You might want to set up a pre-prod or a sort of a mimic your production get that setup ready to make sure you can load test that. Uh, Make sure you set up your scaling configurations the way you want your production infra to scale. You set up those settings, scaling rules, or anything that you want to for your test setup as well. You identify what are your test scenarios, like what is the peak load, what is the concurrency that you're trying for, what is your goal, how much response time do you want, all of those things. What is the try to make sure that you have a pattern which is very close to the real scenarios that user use. For example, when a user is using your website, there could be think time that is included while the user is using the website. So you might want to include some think time within your script as well. So make sure it is as close to the realistic test scenarios and it mimics the actual usage pattern. Coming to data preparation, so you need to prepare a data set that reflects the volume and the structure that your application will encounter in production. So this could be any payloads, events. If you have, if you have, if for example, if you're testing Event Hub, what are those events? You should have some realistic. So if you have database, what queries, what sort of inserts or gets are you doing from database from your application? So have some realistic test data that you should have for your load testing. So once you have all of this, you should be good to start with testing. So let's talk about some different Azure scenarios. The first one we'll talk about is app service. Now, app service is, as you all would know, it is used for hosting websites, APIs, your backend, front end, you can host on app service. It gives you a lot of flexibility to, if you want to say, just host a web application. So most commonly, what we see, the web applications have HTTP endpoints. So let's take an example of app service here. So I'll go to the website that I have. So this is a app service which is a website which is hosted on app service. So as you can see here, this is a .NET podcast application. This is just a demo podcast that I'm using for this purpose of this session. So this is a fully blown website where you can hear podcasts, search, listen, and all of that. So let's see how we can load test this today. Um, uh, I'll show you the JMeter script that I have prepared for this. So this is my demo podcast. Uh, so this, as you can see, this is the URL of my demo podcast application. And I have four scenarios that I'm using here for the demo purpose. I am testing the podcast. How is the response of the podcast page? How is the home page responding, the discover and the search? So these are the four functionalities that I think would be in the user journey. So I picked up these four. So for each of these, I have configured. So these are just HTTP. It's very simple. You can just add a just add an HTTP sampler here, HTTP request, and then you can configure your URL, the path. If it's a post request, you can give your data body data and parameters if you need any. So you can enter all of that. You also can add a header manager for if you want to send any headers. If you have an authentication, you can do that at the authorization header. You can add a cookie manager if you have any. So you can add all of those components within the HTTP request. So you can ideally you would want to sequence it in the way that you feel that the user would perform these actions. And for I have also used a CSV data config set here. So CSV data is when we spoke about having your test data in the real sort of test that you would require for you to mimic the usage patterns. So this is where you can use a CSV data and give the variables that you have in your CSV data, and you can use those. For example, as you can see here, I have two columns in my CSV. One is the name and one is the ID. And these are the names of the podcasts. I've called it shows. So name and ID of that. So I can use the ID in here. So for example, when I'm going to a specific podcast, I'm saying that, hey, this is the ID of the podcast. And so I'm instead of hard coding, I'm providing a list of values from the CSV, and the script will pick up each one by one. So as you can see here, for example, in the search page, I'm searching for a specific podcast. So I'm giving a name. So this is how I'm searching for a podcast. So uh, yeah, I think this is how you can configure. There could be various scenarios if you have, if your website is behind an authentication, say there is a login scenario, you can add a login action as well here, and then you can always fetch token out of a login response of that, and you can use that token to authenticate for the rest of the request. So that it's one user session within the thread group. So the thread group here is the number of we for a thread group you can define the number of concurrent users. So concurrent users or threads. Threads is a JMeter terminology. Uh, you might know it as concurrent users. So I'm saying 100 concurrent users, and when I run this on Azure Load Testing, I can scale out and I can achieve more than what I've mentioned here. So for this demo purpose, I'm saying 100 concurrent threads, and I'm giving a ramp up period of 120 seconds, and I'm giving the duration as 400 seconds. So this is what my JMeter script looks like. So what I can do is now I can go to Azure Load Testing and I can say create, and I can upload my JMeter script here. So I have already created this. So let me just go through the edit flow and show you how I had created it. Yeah, so this is my test. As you can see here, I have uploaded my JMeter script, and I've also uploaded my CSV input data file. Now I have an option if I want to split the CSV between test engines. What happens is if I have more than one engine and I don't want each engine to use the same data, then you can select this option. While running the test, Azure Load Testing will split the CSV file evenly between all the engines so that each engine has unique data. So you can use that if you want. Um, Coming to parameters, though I don't have any in my script, you can still uh, parameterize anything in your script using environment variables. If they are non-sensitive, if there's any sensitive data, then you can parameterize using secrets. You don't have to hard code these. For example, if you want the same script for your uh, test and your staging environment, then you don't want to go and change the URL every time in your script, then you can just parameterize that URL and provide it here as environment variable, and you can change that at runtime. If your website or your endpoint requires client certificate authentication, then you can also give a specify a certificate from the Azure Key Vault here. Coming to load, now when I said that I can scale out from Azure Load Testing, I can increase the load here by increasing the number of engines. So I had mentioned 100 threads in my JMeter script, and I've selected 5 engines here. That means that total 500 concurrent users would be hitting my endpoints throughout the test. So that's how you can scale out. Currently, Azure Load Testing uh, enables you to hit up to 100K concurrent users. You can just uh, select up to 400 engines here. So you can achieve really high scale load, which helps you, especially in scenarios where you have some holiday shopping sale, a Black Friday sale, or something of that sorts. You can uh, test with high virtual users here. Coming to test criteria, now this is where we spoke about the goals that you want that you want to set for your application. So you can have different goals like performance metrics like response times, error rates, throughput, and all of these could be different goals that you might want to define. So what you can do here is you can provide your test criteria here, and when once the test run completes, we evaluate uh, if the threshold was exceeded. If it was exceeded, we mark it as fail, so that you can be alerted and you can know if you want to debug further to see what went wrong. Coming to monitoring now, since it's a website and my website is hosted on app service, I can now uh, monitor the metrics directly from here. I can see how my app service performs. So JMeter gives you the client side metrics, which is what was the response time, what was the error rate, how many requests were generated, how many requests per second were generated. So all of that you get from the client side. But from the server side metrics, like how much was the CPU percentage of my app service? Uh, what was the memory consumption? Were there any requests that were throttled? So these sort of insights you don't get just when you run this JMeter script, say locally or from anywhere else. In Azure Load Testing, the benefit is if your application is hosted on Azure, we can provide you the server side metrics as well in a single view, and we'll take a look at how it looks once you run. So since my app is hosted on App Service, I've selected the App Service, but there's also a SQL database that is there uh, behind which has the actual podcast data. So I have added my SQL database as well here. So yeah, this is a way where you can test like your database is also getting tested, but it is doing through the application. Later on in the session, we will see how we do individual database testing. So let me take you through a run that I had ran earlier. So if you can see, this is a run and this failed. So I see that uh, all of my values have the thresholds were exceeded. I see the error rate is 59%, so that is very high. So there's certainly something wrong. My application is not able to take this much of load. That is what I can understand from the first glance. So as you can see, it was just 500, but still my application through a lot of errors. And these are mostly 500. As you can see, these are 500 errors, which are server side errors. So the application was not able to take that load. So app service started giving 500 errors. So as you can see, let's see now the server side metrics. So we spoke about the client side. These are what JMeter reports. But Azure Load Testing gives you insights into server side metrics as well. So this is what, as you can see, there were a lot of 5xx errors. Um, I see the response times also were very high. And okay, so this is what we were talking about. You see your app service plan. The CPU percentage was very high at some point of time when the load was completely ramped up to the peak. It was 100%, around 100%. We also see the memory also shot up at one point of time. So my app service is at a very low skew. So that's the reason it's not able to take even like 500 um, virtual users. So this could even if you are at a higher skew, maybe it would be able to take 500. But if you want to test for say 100K users, then you definitely face a similar issue where maybe you realize from here that your skew is not um, according to what you want it to be able to handle, the load you want it to be able to handle. So you can now go and adjust the skew. Maybe if I upgrade and I uh, take a bigger skew, then my app service will be able to take this load. So this is the insight that you can draw from here. If you see now, if you see here, even the database, the SQL DB also maxed out on the CPU. So that means that you might have to increase the um, uh, mm, skew for your CPU as well. So these are some indicators which will help you pinpoint exactly where the bottleneck is. So just a quick recap for going back to the presentation. So let me just Yeah. So going back to the presentation, some performance metrics for app service that you should be looking at is CPU utilization, memory usage, very important for you to identify if you need to scale up and take a better skew. Uh, the network metrics also matters. The bandwidth, the latency of network can also affect your response times. So you should also make sure that the latency is low and there's no loss in data as such. Uh, Disk space, if there is any operation where you're writing to the disk, then you should also look at the disk space and all of these IO operations that are you're performing. So running out on disk space can also affect your application performance. uh, Scalability coming if you have any scale rule scaling that you have configuration that you have set, you might want to make sure that you want to monitor if it is being scaling, whether it is vertical or horizontal scaling. You should make sure that your app service is able to scale. So these are at a high level uh, common metrics that you would want to measure. Of course, it might depend on your app, and it could vary from app to app. But these are some important ones that you should definitely monitor when you're load testing. So that was about app service, and app service is still pretty straightforward because it is uh, you mostly use HTTP protocol for testing. Now let's take a look at Azure Service Bus. Now, Service Bus is a messaging service which helps you. You can just queue messages in the service bus and then messages are processed. So this is a slightly different, though service bus has an HTTP endpoint as well. But the best way to test a service bus would be an AMQP protocol. Now, JMeter does not support AMQP protocol out of the box, but there are a lot of community plugins that enable you to do that sort of testing. So let's look at uh, a JMeter script which tests a service bus. So this is my this is my JMeter script. So as you can see here, I have something called Azure Service Bus Sampler. Now this is something that I've added. So this is a community sampler for Service Bus Event Hub Storage Queue. So this enables you to send AMQP messages using AMQP to Service Bus or Event Hub. So I have downloaded this plugin and I put it in my JMeter folder, the lib extension folder of JMeter, and from there, I was able to add a Azure Service Bus plugin. So, when you upload this script to JMeter to Azure Load Testing as well, you will have to upload. These are called custom plugins or custom jar files, and you can actually do your own custom jar file as well if you want any code to be anything that you want to customize that JMeter does not give out of the box. You can always write your custom jar file and upload that and use that. So that is very good in terms of extensibility that JMeter provides. And you also find a lot of since JMeter is open source, there's a big community which has developed a lot of these plugins that you can use as well, and you can customize those to your requirements as well. So let's look at what how we are testing Service Bus here. So so this is my Service Bus sampler. I just provide my Service Bus namespace. So this is your Azure Service Bus namespace resource that you have in Azure Load Testing. If you can select if you want to set send messages to a queue or a topic, and you select the queue that you I selected queue, and then you can give the topic name or the queue name here. I've selected protocol as AMQP. And there are different auth types. There is either Azure AD credential, or you can use shared access signature. You'll have to create a key. You can go to Service Bus and just create a key there. I've created this key called send access key. So this key only has access to send messages to my Service Bus. It cannot read anything from there. So I have created that key, and what I've done here is here I haven't entered the key as such. What I've done is I have given I have defined a user defined variable because I don't want to put sensitive information into my JMeter script, because this script could be shared across my team. It can be checked into my repo, and I don't want sensitive information there. So what I've done is I've used a user defined variable, and I've put secret, and we'll see how we can do that in load testing. Uh, so I've put it in a secret, and I've actually the value here is the name of the user defined variable. So that's how I'm accessing the key here. Once I've done that, I can now add messages. So I've added a few sample messages that I want. And yeah, you can configure the number of threads here as well. So I've define 150 threads for my uh, uh, thread group, and I say duration for 120 seconds. So what happens, these 150 threads would continuously send message to my queue for 120 seconds. If you don't want it to be based on a duration, what you could do is just say 150 threads and remove the loop count infinite, just uncheck that and say um, I want my loop count is 10. So 150 threads would send messages 10 times, which would be 1500 messages. So if you have a requirement on the number of messages you want to test, you can select that and you can configure that. So now once I have configured my uh, JMeter script, now I can go to Azure Load Testing. Let's go back to our resource, and I have created the Service Bus test as well. Let's take a look at how this looks like. Yeah, so here in this is a little different. Here what I've done is I have uploaded the JMeter script that we saw just now, but I've also uploaded the uh, jar file. So this is a jar file that I've downloaded from the public repo for this plugin, and I've uploaded the jar file here. One thing to note about this plugin here is that the service bus sampler returns a the response that is returned. It does not give a 200 code for the successful response. The code is the response code that is returned is basically empty. So what you could do is you could add a GSR 223 post processor where you write some script uh, to update the response code. So what I've done is if the uh, a response that is received is successful and a response code is basically null. So what I'm doing is I'm setting the response code as 200 just to identify that this is a successful response. So I have just checked if the response, though it is, so this is one limitation. So what we are planning to contribute back to the sampler to make sure that this is included as well. So that's the reason we have a JSR 223. JSR 223 enables you to write a script and do any sort of custom logic that you want to do that you couldn't do within a sampler or any other element that JMeter has. So this allows you to do custom processing on a response or any other script that you might want to write in your JMeter script. So coming back to this, so here is where I upload my jar file, I upload my JMX file, and now this JMX file should be able to work with this custom plugin. So remember where you said that there's a secret called send access key. So this is my secret. This is the name of my secret, and I have put it in a Azure Key Vault. And what happens is I have enabled managed identity on my Azure Load Testing resource and given access to the Key Vault to for the managed identity. So now what my load testing resource can access the Key Vault when the test is running and fetch the secret from there and then use that secret to provide to the JMeter engine. So this enables you to pass sensitive information in a secure way. So once I've done that, now I can configure how much load. So for example, I had 150 and I have 150 threads mentioned in my JMeter script. I can now scale out to use as many engines that I want to multiply the number of concurrent users. And I can mention any other criteria. So what I've done is I have added my service bus namespace here in my monitoring. So this is how I've configured my service bus test. Let's take a look at the result. So, so as you can see, 8 engines, 150 threads per engine. Total messages that were sent were around 30K. And so the client side metrics here don't really give a lot because it's just sending messages. It's an asynchronous sort of process. But then I see that out of the all the messages that were sent, there were like around 14% of them were not successfully sent. And that's something that we might want to look into. So this is how it looks from the client side, but in this case, server side metrics make more sense to monitor. So as you can see, we can monitor how many incoming requests, incoming messages were there. Uh, if there were any throttle messages, as you can see, there were quite a few throttle requests that happened. Um, uh, and then you can also see what was the latency. These are some of the important metrics that you might want to check for server side metrics for Azure Service Bus. So I also see, I can also monitor if there were any dead letter messages. Basically, if the number of retries are exhausted for your Service Bus messages, then they go into dead letter messages. So you can configure that and see. So most importantly, I can see that there were a few ones which resulted in error. So maybe my service bus is not able to process. So there are a couple of configurations that you can change on the server side for service bus, like how many connections do you allow at one point, how many retries do you want. One reason is I had set my retries very low. So once the retry count finishes, then it basically it those messages are failing. So these are some things that you might want to look for service bus. Uh, so message throughput gives you an idea about how many messages are being processed in say 1 second. So there's something called MPPS, messages processed per second. It's very equivalent to requests per second in say HTTP. What is a queue or a topic length for the service bus? A very long queue, it might give an indication that it is not very efficient. Uh, is there any throttling? As you saw, there was throttling for the service bus that I used. Uh, how is the dead letter queue usage? Is it very high? So that could give indication that there's some issue where messages are going into the dead letter queue. um, and also resource utilization. So the service bus that I showed could have issues with CPU or memory, but since it is at the basic tier, I'm not having insights into that. Azure Service Bus provides resource utilization only for the premium tier. So if you are in a premium tier, ideally uh, for a production workload, you would have a premium tier. So you will be able to see how is the resource utilization, the CPU memory, and if that is a bottleneck, you could always allocate more resources for your service bus. So these are some important uh, metrics that you can monitor for service bus. Uh, Apart from these, there could be some other, like, for example, is there any authentication failures or anything that is happening? Again, specific to your application, you can select which ones are more important for you. So this is how you can test a service bus with an AMQP protocol. So the similar one would apply for event hubs. I'm for the lack of time, I'm not taking you through event hubs in this session, but there's the same community plugin that you can use for event hubs as well, and you can test event hubs as well with the same plugin. So it is a very similar setup, and you can test your event hubs as well. Moving on to SQL database. Now, SQL database is uh, databases are used almost everywhere. So it's very important. If database is not able to scale, it is very the application response time basically increases a lot. So it's very important to ensure that your databases are able to handle the load. So in this uh, uh, session, we'll look at how you can test Azure SQL Database. We did look at Azure SQL Database in the first, where we were talking about app service, but here we see how you can do it using a JDBC driver. So let me quickly switch to the JMeter script for SQL DB. Yeah. So this is my JMeter script. So basically, in your JMeter script, you will have to add a JDBC connection configuration element. Um, uh, so in this, what happens is you will mention how you want to connect to your database. So basically, here is what my connection configuration looks like. So I'm giving the URL of my database. I uh, mention what is the JDBC driver class, and then I give my credentials, which is username and password. So again, password is sensitive. You can keep it inside a Azure Key Vault and just give the secret name here. So you can establish connection to your JDBC. Uh, you can establish a JDBC connection to your database using this connection configuration element. Now, uh, going to okay, so the next one here would be now you can add a thread group, and in the thread group, you, like we had added an HTTP request for app service, similarly here you add a JDBC request. So you can do different transactions, different queries you can write here. So I have 4 transactions here. I have uh, where I'm selecting a product. This is again a dummy database that I have created. So I'm selecting a product, inserting select customers, select order details. So these are all just select queries. This is an insert query that I have. And I'm also using my CSV data config like we had in the earlier scenario. I'm providing a CSV data config set, and in that has like a lot of um, values here. Like you can see name, product number, color, product category. All of these are variables in my CSV. So I can provide that these, if you want to test, for example, insert you can always use the names that you have from your CSV instead of hard coding that here. That will also help you avoid any redundant data being inserted into your, or any errors that might occur because of adding same values again and again. You can use a CSV data set. Um, so here you also have to mention the, basically there's a jar file that you can download. Uh, it is available on Microsoft learn.microsoft.com. There's a jar file that is basically the library for the JDBC driver. So you'll need to mention the library of path here. So if you're running this on Azure Load Testing, you can directly give the jar file name here. If you're running in local, you'll have to give the path to the jar file, the local path to your jar file. So since I'm going to run it on Azure Load Testing, I've just provided the jar file here. And now I can go to load testing resource and I can see how I can create a test for testing my SQL DB. So yeah, so this is my test. Again, looks somewhat similar. I have uploaded my JMeter script here. This is my JMeter script that we just saw. This is the CSV data file that we spoke about. So I want to provide some input data file for my queries. And I have uploaded the JDBC jar file here. So just you can just upload this and then you can run the test. It uses the JDBC, establishes a JDBC connection and allows you to test. So instead of going through the entire thing, let me take you through how the run looked like and what are the metrics that you should focus on for testing a SQL database. So as you can see here, there were total of 29K odd number of transactions that happened, and of which 15 percent were failures. So I can see that, as you can see, they were the the response time did reduce, but there were a lot of failures, and I can see that in my error. So this is basically a SQL failure. The SQL DB returns this when there are too many requests. So what is happening basically? I can see that my basically the request limit for the database is has been reached, and that's why it is reporting failures. So I can now look at what happened in the server side. As you can see, the CPU percentage like quickly ramped up and it reached the max 100%. The DTU, we'll talk about what is DTU. So the DTU percentage also was 100%. I see the data IO was fine, but then the log writes was also fine. So there is some issue with the DTU. DTU is basically an abstraction on top of all your CPU, your memory, your log IO. It's an abstraction over that. So DTU is basically database transaction units. So you can set a limit, and your pricing tier also depends on what is your DTU limit. So as you can see, my database is not able to take this much load. So ideally, I should go and increase the DTU's limit for my database, and then it will be able to take this load. So as you can see, CPU here is a big issue. The remaining ones are fine. The CPU is very high for my database. So basically, if I increase the DTU, uh, there's a proportionate increase in the CPU as well that is allocated to my database, and that will help in improving the performance. So I'll be able to reduce the errors if I increase this DTU on my SQL uh, SQL DB. So this is how you can identify what exactly is the issue with your database, and you can take actions to fix that. Let's look at some important metrics as we spoke. Performance metrics that you should look at. Some important ones are DTU percentage, CPU percentage, data IO, and log IO. These are some important ones that you would want to monitor. Some others would be uh, basically how many deadlocks you can monitor. What was the deadlock? Uh, 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 how is the index usage? How is are there any block session? How many connections are being active at one point of time? So these are some more that you can look at, but these will basically help you identify what is the bottleneck and what action you should take to improve the performance. Okay, so I think we are towards the end of the session. This is the last demo. This is end-to-end testing of APIM. There's an API that is hosted on APIM. The API then sends a message to Service Bus. The Service Bus there's a function which is basically triggered on which has a service bus trigger configured. So every time a message is sent to the service bus, the Azure function is executed, and the Azure function goes and inserts data into the Cosmos DB. So this is an end-to-end integration of services. So let's take a look at how you can test this end-to-end architecture. Let me open the JMeter script. Yeah. So this is very simple because you're just triggering the API directly. You can just directly use the HTTP request to trigger the API. So I've used this is the endpoint or the domain, and this is the endpoint that I want to target. So this is my endpoint, which basically adds a message into my service bus queue. The name of my queue is demo queue. So I've just configured the endpoint to add a message to my service bus. And this is the JSON body. This is a post request. This is a JSON body that I'm providing. Uh, so I can just go ahead and provide that. So it's as simple as that. It's a very simple uh, file. I have 100 threads configured. The duration is 360. Ramp up time is 30 seconds. So just a small quick test that I'm running on my API. So this is what the test looks like. Let's take a look at. So there is no additional files required here. Your like at least for my scenario, I've just uploaded the JMeter script, and then I'm good to go. If you have any data or anything, you can just provide the input files here. But let's look at the test run. So since this is an end-to-end uh, 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 architecture that we are testing, it's very important to see where exactly the performance bottleneck lies. As I can see here, there were around 19% errors, which is very high. Maybe that is not what is acceptable for my uh, performance requirements. I can see how the response time was. I can see that there were a lot of requests that occurred. There were uh, server side errors that happened as well. Taking a look at server side, now this is where you get end-to-end um, insights into which component was a bottleneck. You can use these metrics to identify that. As we can see here, this is my Cosmos DB, and I see that the RU consumption for Cosmos DB was very high. The RU is basically request units in Cosmos DB, and I can see that it basically was 100% throughout the test. So Cosmos DB is definitely one of the bottlenecks. I might have to go and increase the RUs for my Cosmos DB. I can also monitor other. Uh, Let me just refresh this. Yeah, I can also monitor other here, as you can see, the service bus again, you can see how many active connections were made. Is there any throttling in service bus? I can also see uh, if there was, as you can see, there was some amount of throttling that did happen, and there were some dead lettered messages as well. So the service bus as well has some issues. So I might have to go and fix the service bus as well. Uh, so in this way, by looking at this end to end, I can identify if there was any issue in my end to end architecture, which. So hopefully, if I increase the RUs for my Cosmos, maybe some amount of uh, errors might reduce. So I can take a look into that, and then I can see if there was any issue with service bus, if functions had any issue, and I can fix those issues. Some important metrics that you might want to look for each of these. I think we did discuss some of these, like the service bus and already, but for APIM, basically it's the API performance. So you should look at what is the throughput response time for your APIs. Client side also gives this. You can look at it from client side and server side as well. Azure functions, you should definitely look at CPU percentage, how much memory percentage, what is a function execution count, basically how many executions happening in a unit time, for example, in a second or a minute. That's very important. Functions, again, uh, you can have a dedicated plan as well. If you don't want a cold start, usually functions takes time to scale. So you might have a cold start in the beginning. If you don't want that, you can also take a dedicated plan to avoid the cold start. Cosmos DB, again, you should look at how is your RU's consumption, partition key usage, if that is applicable, storage usage. You should look at these different metrics and monitor to make sure that none of these are like too high and you are within the limits that you would want to have for your application. So this is how you can test different protocols. So basically, to recap, a lot of protocols are there with JMeter supports natively. For some, you can write custom functionality and have a custom jar. Like for the service bus, we had for the AMQP protocol, since that is not supported out of the box, we saw how we can use a custom jar for that. For JDBC, you can upload the driver and uh, test database scenarios as well. So uh, I'm just taking a look at questions. Before that, just some best practices is, first of all, you should understand your application behavior. So try to understand what is the usage pattern, how are users using it, what is the real scenario, user scenario that you would want to test for. Start small and scale gradually. So ideally, you don't want always have a ramp up time when you are testing for high loads. You don't want the to overwhelm the system with too high loads. So it's good to have a ramp up time. Start testing with a lower load first and try to identify if it's working fine with that, and then you can increase the scale slowly and see if it's able to scale. Use realistic test data as we spoke earlier. Have some test that mimics your real usage patterns. Um, you should always test for error handling and recovery. So you can always, even if you are like breaking your system, you can see if your system is able to recover from that. And just instead of testing the happy parts, also try to test out the error parts as well. That will make sure that uh, you are able to um, test that your application in case there is any issues as well. Emulate real user behavior. Try to add think times to your script. Make sure it is how you real user is testing. And then you can also automate load tests. Put it into your CI/CD pipeline. Make sure that before you go to production, you're able to test it once for performance issues, so that you can catch these issues early in the cycle instead of having you having to discover it in production once it is released. So make sure to have it in your development life cycle and test it beforehand. So yeah, so we are um, yeah, I think we are near to the end of the session. Uh, I'm looking at certain questions. I think, okay, so I think Bala has a question. I think Saloni is trying to answer that as well. Bala is asking, uh, console view while testing. So I'm assuming you want to see some logs while the test is running. So currently, you don't have real-time logs or anything, but after you finish the test, you have logs of what happened. Um, so you can look at that. But if you are looking for something else, please uh, let us know. Okay, so if you, yeah, I think you said you want to see the response code or what's the actual response. So right now we do not, you can download the results and you can see the response code, the response message. The response, providing the response itself could really make the results file very large. So providing it in a CSV file could make the CSV very large and you might not be able to consume it. So we do not provide the response in that, but we are seeing, we are looking into how, what are the alternate ways of where we can give you these results in case you want to debug what happened. Okay, I hope that answers your question, but there are no other questions in the comment section. Maybe we can wait for a minute and then we can close if there are no other questions. Okay, Bala has, I think, clarified response payloads. Yeah. So currently, Bala, we do not have the response payloads, again, for the reason that I mentioned, that the file size could be too large where you might not be able to consume it. So uh, the response is currently not included. But yes, we are, this is a feature request and we are looking into how we can provide the responses as well. If you have any questions or issues, even after the session, you can reach out to us on our feedback uh, portal that we have on developer community. I'll quickly share that link in the comment section. Rashmita, I'm unable to post. Would you be able to post this link?
Yeah, sure, sure.
Thank you. Yeah, I think Bala has comment. Sure, Bala, you can just raise a issue on this portal, and we will get in touch with you, and we can help you identify why your script is failing. Okay, I think we are good. Thank you so much for joining. Rashmita, over to you.
Thank you so much, Nikita, for hosting this amazing session. And thank you all for joining us today. You can watch all the 7 sessions on the Reactor YouTube channel, and I have already shared the link in the chat section. Also, please visit Microsoft Reactor website for more upcoming sessions. Feel free to use the Learn module link shared in the chat section, and also right now it's displayed on the screen. This will give you access to additional resources to take your learning further. Thank you all once again and enjoy the rest of your day.